Hi everyone, it's Joel from 8400 Lights, and in today's Lessons Learned the Hard Way, we're going to be talking about LED voltages. Now I have about 24 of these 10 watt RGB floodlights that I have rewired for use in my display. And I have a couple other videos on the channel about how I've done that. At the end of every season though, I would typically find a number of them would burn out their blue colors and I'd have to replace the LED chip. And I always attributed this to just inexpensive LED chips that I was buying. However, a couple of years ago, I replaced all of my octopus cables and found that at the end of that season, the blue and the green had been burned out on just about every single one of my 24 floodlights. And this caused me to do a little bit more research on what was going on. So what I found is that we've always known we have to drop the voltage on our red color using a resistor. However, because the green and blue run between 10 and 11 volts, I had assumed that driving it straight from a 12 volt power supply would be okay, given that we always have some amount of voltage drop in our cables. However, when I upgraded my octopus cables, I think I started delivering more voltage than the LED chips could handle and burned out the colors. So now we're going to go ahead and fix that. So this is my floodlight that needs to be repaired, and I've got it connected to my tester unit. And if we look here, we can see, okay, we have a red, we do not have a green, and we do not have a blue. So both of these colors are burned out. So the first thing we're going to do is go ahead and disassemble this unit. So here you can see this little bus bar that I use to connect the lines from my RGB chip to the lines coming in from my connector. And this is the resistor that I use to drop the voltage for the red color. And note that just simply jumps across. And we're going to disconnect all of this as well because we are going to rewire this a little bit differently when we put it back together. Now that I have everything disassembled, I'm going to go ahead and replace the RGB chip with this unit that I've pre-assembled here. And some people may ask, well, why not just reuse the old wiring that I had in the unit? And that's because I'm upgrading the wiring that goes to the RGB chip itself. So we're going to put this new chip in. Now we have the new LED chip mounted in its case, so we'll start to reassemble this. And the next thing we're going to do is on the back side of the reflector, I always like to put some electrical tape around these edges just to make sure we don't get any cross-shorting between these various connections here, simply because they are so close together. And that is what the back of our reflector looks like. So we'll go ahead and add this and then add all of our top lenses and close all that up. And here is our completed front side of our floodlight. So now we're going to turn our attention to the back side, to our wiring. So before, I had used this little terminal block to jumper this red resistor across from one set of terminals to the other. Rather than doing that, because I'm also adding resistors for my blue and green lines, I'm going to go ahead and just solder this in line with my red, green, and blue connectors here. And then I'll cover this up with a little piece of heat shrink tubing that I added. Very important you remember to add the heat shrink tubing before you solder it rather than trying to do it afterwards. It works a whole lot better. Now, for the blue and green lines, we know we needed a resistor, but how big of a resistor and what kind of a resistor do we need? In this case, there's a thing called Ohm's law, which I'm not going to go into in this video, that you can use to calculate that. And for my calculations, I ended up needing a 3 ohm, 1 watt resistor to get the effect that I wanted. So I have some of those, and now I'm going to solder those onto these two leads here. So here are my 3 ohm, 1 watt resistors that I'm going to add in. And again, remember to add your heat shrink tubing onto these ends first. Here you can see that I have soldered my 2 resistors onto my blue and green wires here. And you can notice that it doesn't matter which end you solder where on a resistor. You can solder to either side and they work just fine. You'll also notice when I was doing this, I put a little bit of solder on each end individually before I soldered them together. And that's just a little tip to make the soldering process a little bit easier. But now that I have these, I'll go ahead and heat shrink this tubing down over it to protect these connections. So here are our 3 lines with our resistors added and our heat shrink tubing applied. So now we're going to go ahead and reconnect this to the pigtail coming in. So here is our pigtail, and we're just going to start by feeding that back through the housing like this. And then we're going to go ahead and utilize this bus bar again to connect our pigtail to the lines that run to our RGB chip. And in doing this, note that it doesn't really matter what the order of these colors are, just so long as you match red to red, green to green, blue to blue, and black to black. There, we have one side of our bus bar connected. Note that we have a spare set of lugs here. This is from where we crossed the red resistor on the last time that we're just not using, so those can just hang out there. Now we'll go ahead and connect our leads to our RGB chip, and note that I've trimmed down the leads on my resistors here, but I've also taken and doubled them over so that there's a little bit more wire there when we go into the bus bar. The next thing I like to do before final assembly is do a quick test to make sure everything is working. So, red, green, and blue. Blue is hard to see, but it is there. So now we'll go ahead and close up this back cover and we'll be done. Here is our reassembled floodlight, and we will do one more test at 12 volts. So So there's green, there's blue, and there's red. So it is now fixed. I hope you have enjoyed this Lessons Learned the Hard Way video on LED voltages. Please subscribe and like if you have, and enjoy our other videos on our channel 8400 Lights. Thanks!